Welcome viewers, today we shall solve this problem. The problem is, let z be a complex number such that z, z square, z cube are collinear, that is they lies in the same straight line, they lie in the same straight line in the complex plane, so that z is a real number. We have to prove that z is a real number when z, z square and z cube are collinear, that is they lie in the same straight line, and also z is a complex number. We have to prove that z is a real number, z is a real number. Now, let us begin. Here we can consider z equal to a plus ib, where as z is complex number, so z can be written as a plus ib, where a b belongs to real number, that is a b are real number, that is a and b are real number, and z can be written as a plus ib, as z is a complex number, I is also square root of minus 1, that is imaginary number, minus 1. Now, z square equal to a plus ib square, which can be simplified as a square minus b square plus 2abi into 2ab, and also z cube equal to a cube, a plus ib whole cube equal to a cube minus 3a b square plus I into 3a square b minus b cube. So, z square, z cube can be expressed in terms of a b, where a, b are all real numbers, and z equal to a plus ib is a complex number. Now, as z square all are complex number here, lie in the complex plane, that is Argand plane. Complex plane is called Argand plane. So, we can consider these as 3 points in this plane. The coordinate of these 3 points, also named as 3 points named as ABC respectively, A, B, C respectively, in this plane. So, ABC are 3 points which represent these 3 complex number z, z square, z cube, and also ABC lie in the Argand plane, that is complex plane. and so the coordinate of A, coordinates of A, B, C are AB A square minus B square 2AB and A cube minus 3AB square 3A square B minus B cube respectively. These are the three coordinates of the point ABC which represent the three complex number z, z square and z cube. And these three complex number, that is ABC, that is three complex number can be represented by the 3 points in the complex plane, that is Argand plane. So, as z, z square, z cube are collinear, so we can say also ABC are collinear. As z, z square, z cube are collinear, so ABC are also collinear. So ABC are collinear. ABC are collinear, and we have the condition for collinearity of 3 points. The condition is these 3 points, the triangle formed by these 3 points, the area of the triangle formed by these 3 points is 0. If area is 0, then 3 points are collinear. So, this is the condition. So, the triangle formed by these 3 points, area of the triangle, area of the triangle formed by the 3 points A, B and C is half into A into x1, y1, x2, y2 and x3, y3. So, area of this triangle is x1 into y2 minus y3, that is 2AB minus y1 minus y2, that is minus 3a square b plus b cube plus x2 is a square minus b square into y3 minus y1. y3 is this 3a square b minus b cube y3 minus y1, that is minus b, plus x3 is a cube minus 3ab square into y1 minus y2, that is b minus 2ab, This is the area of the triangle, and this area must be 0 because ABC are collinear. So, this area is 0, this equal to 0. So this is equal to 0, area equal to this, and also half b into, if we multiply these terms, we get 2a square minus 3a cube plus ab square plus 3a4 minus a square b square minus a square minus 3a square b square minus plus b4 plus b square plus a cube minus 2a4 minus 3ab square 3ab square plus 6a square b square equal to 0. 6a square b square equal to 0. So, half b into 2a square minus a square is a square minus 3a cube plus a cube which is minus 2a cube and 3a4 minus 2a4 which is only a 4 and 6a square b square minus 3a square b square minus a square b square which is 2a square b square 2a square b square and minus 3ab square plus ab square which is minus 2ab square and rest terms are only b4 plus b square equal to 0. This is equal to 0. So, we can write b equal to 0 or a square minus 2a cube plus a4 plus 2a square b square minus 2ab square plus b4 plus b square equal to 0, which implies b4 plus b square plus b4 plus b square into 1 plus 2a square minus 2a. 1 plus 2a square minus 2a and a4 minus 2a cube plus a square equal to 0. So, we can also write b square plus b square into 1 plus 2a square minus 2a minus 2a plus a square into a square minus a minus 1 whole square, a square into a minus 1 whole square equal to 0. We can consider it as a quadratic equation in b square. It is a quadratic equation in b square. So, we have the solution of this equation. We can solve this equation using Shridharacharya's formula. Using Shridharacharya's formula, we get the solution of this quadratic equation in b square. So, b square equal to minus 1 plus 2a square minus 2a plus minus root over of 1 plus whole square minus 4a square over 2. This is equal to minus 1 plus 2a square minus 2a plus minus if we simplify this expression, we get 1 plus 4a4 plus 4a square plus 4a square minus 4a minus 8a cube. From this term we get minus 4a4 plus minus 4a square plus 8a cube over 2. This is equal to minus 1 plus 2a square minus 2a plus minus, here many terms are cancelled out, here 4a4 cancelled out, 8a cube cancelled out, 4a square cancelled out. Only we have 1 plus 4a square minus 4a over 2. This is equal to minus 1 plus 2a square minus 2a plus minus, this is a whole square, perfect square. This perfect square is 1 minus 2a whole square over 2. This is b square equal to this. So, b square equal to, we have got b square equal to minus 1 plus 2a square minus 2a plus minus the whole root over of perfect square, the whole square is 1 minus 2a, that is square root of 1 minus 2a whole square equal to 1 minus 2a, 1 minus 2a over 2, or b equal to 0. Here also b equal to 0 or this. Now, b square equal to minus 1 minus 2a square plus 2a. We can consider two sign, plus and minus. If we consider plus sign, we get 1 minus 2a over 2. If we consider minus sign, we have got also a value, we have also got a value of b square minus 1 plus 2a square minus 1 minus 2a square plus 2a. If we consider minus sign, we get minus 1 plus 2a over 2, or b equal to 0. Now, this is minus a square and this is minus 2a square plus 4a over 2 or b equal to 0. This is equal to minus a square. This can be written as minus a minus 1 whole square. This is, or b equal to 0. B square. Now, when b square equal to this, that is b square equal to minus a square minus a minus 1 whole square, then we have to consider b not equal to 0. We have to consider b not equal to 0. This is. Now, if b square equal to minus a square and minus a minus 1 whole square, a square and a minus 1 whole square as perfect are all perfect square, and also this a can be 0 or a minus 1 can be 0. If a is 0, these are b square is a perfect square so b square cannot be equal to minus a square or minus a minus 1 whole square, because these two quantities are negative, because minus a perfect square minus a perfect square, a negative quantity, or may be 0. These may be 0 when a equal to 0. But when a equal to 0 or a minus 1 equal to 0, then b square equal to 0. B square equal to 0, but which cannot be possible, because we have considered b not equal to 0. So, b not equal to 0, this contradicts each other, this contradicts. So, b equal to 0 contradicts b not equal to 0. This is not possible. This is not possible. So, a not equal to 0 and also a minus 1 not equal to 0. So, b square equal to minus a square minus a minus 1 whole square is a negative quantity. It is a negative quantity. So, this is b square equal to minus a square or minus a minus 1 whole square is a negative quantity, which is not possible, which is not possible when b not equal to 0. B not equal to 0, b square equal to this, which is not possible. B square cannot be equal to minus a square or minus a minus 1 whole square, because a square and a minus 1 whole square, minus a square and minus a minus 1 whole square are all negative quantity, and also a and a minus 1 cannot be 0. So, b square cannot be equal to minus a square or minus a minus 1 whole square, which is if this, then it is not possible. B square equal to this equal to not possible. B square cannot be a negative quantity, because b square is a perfect square. So, only b equal to 0. So, only b equal to 0, but b square not equal to this. B square not equal to minus a square or minus a minus 1 whole square, only b equal to 0. So, complex number becomes z equal to a plus ib equal to a plus I into 0, which is a, and a is also a real number. So, z equal to a is a real number. So, under this condition, z cannot be a complex number, that is imaginary number. Z is also a real number. Z can only be a real number. Z cannot be complex number or imaginary number when z square, z cube are collinear. If z be a complex number and z square, z cube are collinear, then z cannot be a complex number, but z is a real number.